Greetings, girl, and welcome to my world of phrasing right up to bat. It's the daisy age, and you're about to walk top stage, so wipe your lottos.
And welcome to the video on the cross product. So just like the dot product that we've learned about, the cross product is also an operation between two vectors. Okay, so but the only difference between the dot product and the cross product is kind of a whole world of difference, because the dot product you take in two vectors, so input two vectors, and you get out a scalar. It spits out a scalar, okay? But the cross product, on the other hand, you input two vectors likewise, right? So input two vectors, but instead of getting a scalar out, we get another vector, okay? And that is our resultant vector from the cross product. Okay, so that's an important difference between the dot and the cross. And now, as for the technicalities of the cross product. So first, what we'll have to know is something called the determinant. Determinant. And we won't go into great detail or anything about what the determinant is exactly. We'll probably go over that in future classes. But a rough definition is just it is the difference of diagonal product. Okay? And so I'll show you how to compute a determinant. So there are infinite, I guess, types or dimensions, right? But we're going to start with the basic one, 2 by 2. So let's say we have A, B, C, D. This is just an arrangement of numbers here. And to compute the determinant, you would have to take the first diagonal, always leading down and to the right, okay? So you take the product of those two that I just circled, so A times D, and then we're going to subtract our other diagonal, the product of our other diagonal, B times C, okay? So that's for the 2 by 2. And then let's go on to a 3 by 3. So it gets a bit more complicated. So let's say we have A1, B1, C1, A2, B2, C2, and a third row, A3, B3, C3. Okay, so now for the determinant of a 3 by 3, this is called a 3 by 3 matrix. And so what you'll have to do is first, you always start at the top left, okay? So we're going to circle this top left number here, A1, okay? And when you circle it, you write it down, okay? So A1's there. And then what we're going to have to do is anything right in line, like horizontally or vertically, we're going to kind of like ignore right now. So I'm just going to put a little dashed line through them. Okay, so we're going to ignore those. And what you write next to, W-R-I-T-E, next to our A sub 1 is it's called a minor matrix. So this everything in this square down here, in this bottom square. Okay? So we're just going to write that down again as a 2 by 2 matrix. So we have B2, C2, C2, B3, and C3 left. So we're going to write that as a little one, like a 2 by 2. So we're kind of just breaking it down, okay? And then the next step, so we'll expand that after on the following step, I guess. Anyways, so we started with A1, and now we're done with that. We wrote down all we need to, and then we're going to write a minus sign, because we have alternating signs between the terms. Because we started with a positive, you always start with the positive, and then you write a negative here. And now we're going to go to the right and circle B sub 1. Okay, so we're going to write that guy down. And now we're going to do the same thing, cross out anything horizontally and vertically within that row. So see here, now we're left with A sub 2, A sub 3, C sub 2, C sub 3. So these ones, sorry if the other markings are getting in the way from the previous step, but every time you circle a new number, or letters in this case, every time you circle a new term, the markings start over, okay? So now we're left with A sub 2, A sub 3, and C sub 2, C sub 3, okay? So now we're done with the second term. Here's our another 2 by 2. And the last term is just going to be plus, because we have alternating signs, and we'll go over the last circle here. So that's going to be a C1, C sub 1, and I'll write the little 2 by 2 down here. This is multiplied times this, okay? And we're going to cross out everything in line with C sub 1, horizontally and vertically. So we're left with, if we cross them out like that, we're left with this bottom square down here. Okay, so A sub 2, A sub 3, B sub 2, B sub 3. Okay, so here's another 2 by 2 matrix. Okay, so from this point, we're just going to basically implement what we know about 2 by 2 matrices and how to compute their determinants. So now we have, starting from the beginning, A sub 1 times what? And we have to take the product of the first diagonal, so B sub 2 times C sub 3, and subtract the product of the other diagonal. So that would be C sub 2, B sub 3. Okay, so that takes care of the first term, and now we're moving on to minus B sub 1. We have to do the same exact thing for this 2 by 2. So we're going to do A sub 2, C sub 3, A sub 2, C sub 3, minus the product of the other diagonal, and we have a C sub 2, A sub 3. Okay, and for our last term, we have plus C sub 1, and then the determinant of this little 2 by 2 is going to be A sub 2, B sub 3, A sub 2, B sub 3, minus, and finally, B sub 2, A sub 3. Okay, so it might look a little bit, or a lot bit complicated here, but that's just because we have a bunch of variables representing numbers. It becomes easier with numbers actually, because it looks more tangible. Okay, so now you might be thinking, okay, that's great. I learned about this thing called a determinant, and why did we do this? Basically because you use the determinant in the cross product. Okay, so cross product of or between V, and I'll call vector V A sub 1, B sub 1, and C sub 1, and W, and I'll make that A sub 2, B sub 2, and C sub 2. Okay, so here is the cross product between V and W. So V crossed with W, all right, is going to equal, and this is the way we set it up. So here, see how we don't have enough for 3 rows, because we're going to write them like this, A sub 1, B sub 1, C sub 1, and then we write V across here in the middle, and then we write the W at the bottom, our second vector along the bottom, those components, okay? And on the top row, we actually just fill in the unit vectors going along the axes, okay? Remember, I stands for 1, 0, 0, pointing in the unit vector pointing in the x direction. J hat stands for the unit vector in the y direction, so 0, 1, 0, and K stands for the unit vector in the z direction, so that would be 0, 0, 1. Okay, so anyways, this is just the process you go through whenever you're taking the cross product between 2 vectors. You always write the I hat, J hat, K hat on the top, and then you write the first vector in the middle row and the second vector in the bottom row. Okay, so now we're just basically going to compute this 3 by 3 determinant. Okay, so we're going to start at the top left, and we're going to write down whatever we see there, so that's our I hat, and then we're going to dash out anything vertically in line with it or horizontally in line with it. So we're left with this 2 by 2, this minor determinant, so that's B sub 1, C sub 1, B sub 2, C sub 2. Okay, and then we have to have this alternating sign, right? So then we have our J hat, that's the next one we're going to circle. Then we cross out anything horizontally in line with it and anything vertically. Okay, so we're left with A sub 1, A sub 2, C sub 1, C sub 2. All right, and for the last term here, we have a plus K hat. That's our last one we're going to circle. So we're going to cross out everything in line with the K, so we're left with this bottom square, which is A sub 1, A sub 2, B sub 1, B sub 2. Okay, so now we're just going to simplify here. And I'll just write this down quickly because now we know how to do 2 by 2 determinants. So this first one's going to be B sub 1, C sub 2 minus C sub 1, B sub 2. And then we have a minus J hat. And for this one, we'll have a sub 1 c sub 2 minus c sub 1 a sub 2. And the last term is going to be k hat times a sub 1 b sub 2 minus b sub 1 a sub 2. Okay, you'll get used to it after a while. It's just a process. So let's do an actual concrete example with numbers. So let's say we're finding the cross product between v, which is -2, 1, and 4, and w, which is given by 3, 2, and 5. Okay, so let's set it up first of all. So v cross w is going to equal, and we set up our I hat, j hat, and k hat first of all, and then we enter in what our vectors are. So v goes in the middle, -2, 1, 4, and w goes on the bottom, 3, 2, 5. If you were to switch the order of these, if you were to say w cross v, then you would write w in the middle line and v along the bottom, okay? Alright, so let's continue. So we have I hat, and then what our minors turn out to be, so if you circle I hat, then you cross out these ones, right? So we're left with 1, 4, 2, 5, okay? And then we have our minus j hat, and our minor here, our 2 by 2 is going to be -2, 3, 4, and 5. And lastly, we have plus k hat, and that's going to be, cross those out, so we're left with this minor, which is -2, 1, 3, and 2. Okay? So now that we have this, we're going to continue and follow all the way through. So we have I hat times what? 1 times 5, going this way. 1 times 5 minus 4 times 2. Okay? And then minus j hat. And then this is given by -2 times 5 minus 4 times 3. Okay? And the last one's k hat times -2 times 2 minus 1 times 3. Okay? So if we simplify here, we get I hat times 5 minus 8 minus j hat times -10 minus 12. Okay? And plus k hat times -4 minus 3. Okay? So if we simplify even more, we get -3 I hat, and then this is a -22, but it'll turn positive, right? So plus 22 j hat, and the last one is -7 k hat. All right. So again, the way you write this in vector form is you just pull out the coefficients of each. All right. So we're gonna have -3, positive 22, and -7 is our resultant vector.
May I cut this dance to introduce myself as the chosen one to speak. Let me lay my hand across yours and